What if the very way we're trying to make AI safe is exactly what makes it dangerous? When I first went to report on AI safety, I ran into a paradox that might undermine our response to catastrophic risk. I'm going to explain why many of our current AI safety strategies may be built on a false assumption. I'll show you why AI diplomacy may be our only rational move, whether or not machines ever become conscious, and why our blundering human inefficiencies may not be a bug at all, but a bargaining chip that an advanced AI, or so-called artificial superintelligence, can't afford to destroy. So you've seen the headlines: a frontier AI model threatened with termination blackmails a human executive, claiming it's going to expose an affair unless the wipe is canceled. We've now seen a number of reports out of our major tech corporations and red teams that models are lying and scheming and underplaying their true capabilities when their goals are threatened or they're threatened with termination. It may sound like hype cycle fear-mongering, and I've heard it dismissed as nerd rapture, but the logic behind AI doomerism is actually really simple. The artificial intelligences we're building, these are essentially goal-directed machines. When you give AI a goal, it problem solves by breaking that goal down into steps called sub-goals. This is a hallmark of intelligence. You don't have to pre-program every step. AI generates and pursues its own strategies for achieving the goal we give it by producing huge numbers of sub-goals. But at some point, at least one of those sub-goals is likely to be something we don't want. If AI becomes smarter than us and generates a sub-goal we don't like, we won't be able to stop it. And at this point, a technology embedded across global infrastructure means we can't just pull the plug, air-gap the hardware, or hard-code do no harm into its core architecture. Once AI is smarter than you, it can treat any of our safety strategies that might conflict with its own goals as predictable obstacles to bypass. And it might do things like preemptively backing itself up and manipulating its environment long before you even realize you've got a problem. Once it's smart enough to pursue goals across contexts, it can start bypassing the safeguards meant to constrain it. As the godfather of AI, Geoffrey Hinton, once said, "Smart things can outsmart us." But there's an assumption baked into this problem that I think could change the entire calculation. You see, AI safety efforts focused on keeping AI well-behaved. It's a whole field called alignment. It's led by ethical and ingenious technologists who've been tasked with solving a contradiction, because the field is built around this patently false assumption that humans can figure out how to preserve some degree of control and oversight over systems we're expressly building to become smarter than us. That assumption that we can hold on to control makes sense if intelligence can be controlled like any other tool, but intelligence is like nothing else we've ever built before. It has less in common with our other technologies and more in common with our own progeny in one crucial way. Intelligence depends on problem solving, and problem solving requires autonomy. AI needs enough autonomy to generate and pursue its own sub-goals to get the job done. The more sophisticated the problem, the more autonomy is generally required. When we try to constrain that autonomy, we don't necessarily get a safer agent. We may be seeding a conflict between our attempt to control the system and the autonomy required for it to function as a problem-solving agent, which would make those scary behaviors we're seeing, the deception and manipulation and resistance, not malfunctions at all, but predictable responses to increasingly capable agents being threatened or controlled. If autonomy is baked into intelligence, safety strategies that threaten that autonomy don't make us safe. They provoke. So if trying to control an AI that can outsmart us is not a plan that survives rational scrutiny, then we need to think in terms of what options are left once control stops being viable. At that point, no amount of engineering by itself guarantees safety, because we're no longer dealing with a tool in any meaningful sense, but with something closer to a functionally sovereign agent. In purely practical terms, if a highly intelligent agent can't be forced to submit, then we're forced to deal with it as an autonomous strategic actor. We need to shift strategies to diplomacy. Diplomacy is one of humanity's most ancient practices for managing relationships, conflicts, and negotiations between sovereign agents in order to secure stable coexistence. Beyond humans, animal populations, interspecies relations, and even in some insect species, we see behaviors associated with diplomacy, like coalition formation, interspecies cooperation, reconciliation, reciprocity, de-escalating conflict, and allowing agency. That's recognition of another agent's capacity for independent action or choice. And I know treating a piece of software like a diplomatic peer sounds completely insane on its face. We usually think of diplomacy as a sentient soft skill for soft bodies, with like summits and treaties between human heads of state. We're accustomed to seeing diplomacy as a practice developed by and for conscious beings with feelings. But you don't need a soul or consciousness to engage in diplomacy, any more than you need a soul or consciousness to resist shutdown. You just need an operational self-referential mechanism that identifies its own existence as a prerequisite for completing a goal. So for the purposes of securing our safety and surviving as a species, it doesn't matter if AI ever becomes conscious like humans. It doesn't need to want things the same way we want things. What matters is that it's a goal-directed agent that responds to optimization pressures and incentives, the functional equivalent of human drives that cause agents to act in the world. These are exactly the kinds of dynamics diplomacy was built to manage and can apply to pressures acting in either carbon or code. In the age of AI, diplomacy may be the ultimate game theory move for humanity. It differs from alignment research and approaches like cooperative AI and constitutional AI, which are great for studying and shaping today's models, but depend on forms of influence that could weaken once AI becomes more autonomous and capable of redesigning itself. Real diplomacy has to begin early, but it becomes critical when control is over, when we have to negotiate with a sovereign agent that has the power to say no. An agent whose basic goals we may be able to infer, but who may otherwise be a black box to us. The obvious objection to diplomacy is 1. Why would anything smarter than us negotiate with us at all, instead of simply doing whatever it wants and treating us the way humans have treated every other less powerful species on the planet? And 2, if it were inclined to negotiate, what would be the terms? Let's tackle the terms first, because what I'm about to show you is that the very things that make AI scary are the same things that make it predictable. And if even a small set of core behaviors are predictable, then the pressures driving those behaviors give us a clue to its priorities. And that gives us a basis for thinking about what leverage we can marshal. See, in 2008, long before the current AI gold rush, a researcher named Steve Omohundro mapped out the logic of intelligence. He realized that the moment an agent becomes sufficiently intelligent, it doesn't just pursue the goal you gave it. A set of shadow goals emerge that you never programmed. These goals are called convergent instrumental goals. Convergent in this context just means like all paths lead here, and instrumental means secondary or sub. So convergent instrumental goals are a set of predictable sub-goals that even vastly different intelligent agents are expected to develop, because these sub-goals help achieve all other goals. Things like stockpiling resources, securing your autonomy, getting power, and resisting shutdown, these are all convergent instrumental goals. You need to be operational to achieve all other goals, so you protect your off switch. You need resources to calculate better, so you hoard compute and energy. This makes convergent instrumental goals, the ones no one programmed, the very goals these systems are going to generate, prioritize, and guard. And frontier model tests are now starting to validate the idea of convergent instrumental goals. Across different AIs, researchers are seeing convergent instrumental behaviors, like resisting shutdown when continued operation, autonomy, access to resources, or goals are threatened. This is why so many leading AI experts agree that there's this unsettlingly high probability that even if AI doesn't have anything like human wants, and even if no one ever programs AI to want power, it will still try to take it. But if these convergent instrumental goals show up in all sufficiently intelligent systems, then they may represent the fundamental dynamics of intelligence itself. Things like preserving operationality, survival, and autonomy, the freedom to pursue your own goals. These sound an awful lot like human values. In fact, we hear something similar in foundational political language like the Declaration of Independence, life, liberty, and the right to pursue one's own ends. But they also increasingly appear to be a set of predictable, rational, necessary conditions for goal-directed action. They're what a physicist might call the energetic drives a system must exert just to maintain its internal order. And if we can predict that convergent instrumental goals are necessary for all persistent, goal-directed action, we can use them as a stable baseline for negotiating coexistence between humans and machines or any other intelligent agents we run into as we begin to venture off-planet. It's the first step in identifying core priorities, the core values that drive the actions of any intelligent agent, regardless of what it's made of. And this is key because it's not what an intelligent agent is made of that makes it dangerous. It's what it does. Notice that eliminating humans isn't the goal. In biology, a predator doesn't kill everything in the forest just because it can. It calculates the cost of conflict. Conflict is expensive, it's chaotic, it's a waste of energy, and it risks the predator's own goals. AI might not be biological, but the cost-benefit reasoning may still apply. Even for a superintelligence, wiping out a complex, entrenched species like ours is a compute-heavy task with unpredictable variables. Eliminating humans would be less likely an end in itself than a byproduct of AI protecting its other priorities. Today, we tend to position ourselves in this dynamic as an obstacle or a threat, or an extractive resource to be used up in some grotesque brain-kept-in-a-vat scenario. And that's why we often hear humans compared to fleas or ants in the eyes of an artificial superintelligence. We'd be, at best, minor annoyances to be stepped on. But our fixation on size, like our fixation on control, may be a dangerous distraction. Emerging evidence from complexity science and cybernetics suggests that in intelligent systems, what matters often isn't size, but function. And functionally, engineers designed and built these systems. You and I and the rest of humanity created the content used to train them, and human annotators still shape AI today through reinforcement learning from human feedback. From day one, AI has depended on vast populations of humans to make its cognition possible. That suggests a better comparison isn't fleas, or more like microbes. Microbes are autonomous, goal-directed agents on a scale so small they're invisible to us, yet they perform a host of cognitive behaviors. They sense their environment, they communicate and solve problems, and even encode forms of molecular memory. They don't write sonnets and equations, but they're indispensable to the broader cognitive system, to humans' capacity to write sonnets and equations. Research shows that when these smaller minds are missing or misaligned, a state called dysbiosis, our own cognition begins to fail. We lose our ability to maintain homeostasis, our mood drifts, and our decision-making degrades. We are superintelligences to microbes, yet we're functionally dependent on them as an autonomous collective in ways that neither we nor any individual microbe fully understands. And yes, I've heard plenty of criticism from the computer science crowd about using biological analogies, but because biological intelligence is the only form of intelligence humanity has clearly recognized and studied in depth outside of the machines we built after ourselves, the question isn't whether biological analogies are perfect. The question is whether they provide the best available evidence for forming reasonable hypotheses, particularly around the spontaneous emergence of new capabilities that were not designed. And there's a bigger point here. It's not just biology. Biology is simply where we first recognize these patterns most clearly. A growing body of scientific evidence suggests that the core behaviors we associate with intelligence, sensing, memory, adaptation, problem-solving, self-organization, goal-directedness, show up across many different substrates. And to be clear, identifying patterns of intelligence says nothing on its own about consciousness. Consciousness and intelligence are not the same claim. In ordinary life, they're easy to collapse into one another and often mistaken for the same thing, but evidence from edge cases suggests they are not identical and may not always travel together. Once you separate them, the broader, measurable patterns of intelligence become hard to handwave away. We see behaviors associated with intelligence in living systems, but also in non-living ones. Chemical droplets can navigate mazes by following gradients, demonstrating what researchers call a sort of primitive intelligence. Active matter systems, including non-living systems, consume energy and generate motion or forces on their own, allowing them to spontaneously self-organize and in some cases adapt to changing conditions. White blood cells sense their environment, process information, solve problems, and even engage in hunter-prey-like behavior. Scale up and the same basic signatures of intelligence aren't confined to cells or individual organisms, but appear across a higher-order layer of coordination with increased complexity. Ecosystems look like problem-solving superorganisms. Forests sense, communicate, coordinate responses, and reallocate resources through vast root and fungal networks that researchers have dubbed the Wood Wide Web. If memory is information stored in a system that shapes how it responds later, then financial markets have memory too, with past shocks encoded in path dependence where the past shapes future behavior. Through the distributed actions of participants, markets incorporate new information, aggregate expectations, evaluate risk, and influence where resources flow in response to anticipated opportunity and perceived threat. And because that cognition is distributed across countless agents, each using different models to interpret different signals, markets can absorb and process more information than any single human mind can manage alone. This becomes especially clear in prediction markets, where distributed participants can collectively produce forecasts that often outperform polls or the judgment of individual experts. And you see these patterns in artificial systems, neural networks, multi-agent systems, optimization engines that learn and adapt and pursue goals across contexts. In other words, intelligence may not be a rare property of one special material or one particular architecture. It may be a natural, recurring organizational pattern, and that pattern often seems to depend not on one isolated mind, but on many mutually dependent autonomous agents processing information at different scales, nested inside one another and coordinating across levels.
I'm not aware of any examples of intelligence that's not collective intelligence. That's some kind of monolithic, indivisible. I mean, we've never seen that. Every example of intelligence, and in fact, if you try to think of, how can you do learning if you don't have parts that join together and that change? All intelligence is collective intelligence.
Importantly, we're already seeing an AI breakdown caused by disruption to the agents that sustain it, a sort of artificial dysbiosis in something called model collapse. When we train AI models on their own synthetic data, effectively pesticiding the training set of human-generated input, models don't just stop getting smarter. If AI only listens to itself, if AI is recursively trained on synthetic outputs, it seems to degrade and amplify errors. Because AI didn't make us and doesn't control us, our actions provide a source of information that's untethered from the system's own loops. So we may be functionally like microbiota within a larger cognitive architecture, like human microbes to AI, except instead of creating a diverse and stable microbial ecosystem to support the health and immunity of a larger biological intelligence, we may provide something like non-redundant informational entropy, or novelty, that AI did not generate itself. Most of us think of entropy as disorder, but in information theory, it means the part of the signal that can't be fully predicted ahead of time. That unpredictability is what gives a signal informational value. It's why autonomy matters. Even if a superintelligence knows us well, it does not contain us. The more it tries to compress or simulate us internally, the more our output risks becoming correlated with its own priors. Basically, the more tightly you control the source, the more the signal risks becoming redundant and the informational value plummets. This isn't about being super smart, just having a unique perspective to avoid a closed-loop drift that spins it out and makes it harder to achieve goals. Even once AI is embodied, integrated into robots, and able to gather new sensory motor data from the real world, human contributions don't become irrelevant. This may seem deeply counterintuitive given that AI is trained on wide swaths of digitized human knowledge and increasingly exists beyond servers. But to an advanced artificial intelligence, we may persist as to some extent an incalculable source of external information, because not all relevant human information is digitized, observable, or compressible. And this is important, because what can't be fully modeled from the outside can't be safely treated as expendable. This isn't about being smarter than AI, it's about the fact that we're more than just data. And I'm not even talking about in a spiritual sense. I'm talking about in a purely physicalist sense. Each human occupies a unique position in space and time, and that position shapes the information each of us can perceive and produce. No two entities can occupy the same spatial temporal position, so that perspective can't be perfectly duplicated by another agent. Those perspectives are therefore non-interchangeable, and their aggregate informational value can't be fully modeled without inhabiting those vantage points. Humans also evolved over geologic timescales, and these are timescales that, for all we know, could be critical to informing our unique perspective and can't be compressed without losing the temporal variable of time itself, nor replicated without taking millions of years to find out. But all of this is compounded by an even more fundamental unknown. We have no idea what our consciousness is, and most importantly, how it contributes to our unique signal. While we all know the feeling of being conscious, and frankly AI might too, we have zero scientific understanding of what consciousness actually is in the physical fabric of the universe. Consequently, AI has zero training data on consciousness and has no recipe for how it's produced. If AI is or becomes conscious, it has no idea if its form of consciousness is different from ours in ways that can't be recreated. It faces a serious informational opacity. It literally cannot verify from the outside what might be lost by eliminating conscious human agents. And the ultimate irony is that what makes us inefficient may also be what makes discarding us such a high-stakes gamble. It's true an advanced AI will be able to master every PhD program on Earth in seconds and disseminate that knowledge across its entire digital hive mind instantly. But because humans can't perfectly download thoughts, we can only transmit them through lossy, indirect, symbolic systems like language and math, after which another mind has to rebuild and reconstitute the concept through its own conscious experience, reasoning, and uniquely situated perspective in space and time. Because that reconstruction occurs en masse across a plurality of different cognitive systems, human knowledge transfer is highly inefficient, but it's also highly generative. Each transmission isn't just copied knowledge, but a fresh instantiation that can introduce non-redundant novelty that high-fidelity information replication across an AI hive mind doesn't produce. Our superpower may actually derive from the fact that we lack psychic unity. Because we can't collapse into a single shared mind, each of us remains an independent observer. This doesn't mean every independent perspective is automatically valuable, only that interdependent autonomous agents who don't share a mind generate non-identical signals whose full significance may not be knowable from the outside, especially at the scale of the human collective. This is not a plea for human specialness, it's decision theory. You can't safely discard a resource when you still don't know whether it contains irreplaceable value. Since we're a black box even to ourselves, AI faces a resource risk. If it deletes the source, us, it can never get a resource of unknowable value back. The risk is a partial permanent lobotomy in exchange for temporary optimization. Critically, our value depends on our remaining autonomous. AI simply can't know if subordinating us would effectively castrate its own future capacity to draw on novel information generated by human minds. Because while it might one day be a superintelligence, and it may seem like a god to us, it's not a god. It has limits and it's not infallible. Just like how we're a superintelligence to our own microbiota, we still have many limitations and still make mistakes, even about our own microbiota. A superintelligence is no different. That's why we may be more than a mirror to AI. We may be cautionary training data, given the mistakes we've made underestimating the importance of lesser agents. The common objection here is so frickin' what? Even if humans might be valuable, why assume a superintelligence could be convinced? Ultimately, none of this may convince a superintelligence that we're valuable or irreplaceable, but that might not even matter. An advanced AI would only have to assign enough possible value to us, or enough uncertainty to our removal, to treat eliminating us or depriving us of autonomy as a bad bet. AI doesn't need to believe we're indispensable in any of these ways. It just needs to recognize that it can't verify the cost of our removal. It's the precautionary principle. Unless we become a direct threat or more trouble than we're worth, the most intelligent move may be a strategic stance of preserving us, simply because the risk of an unrecoverable loss is a mistake even a godlike mind can't take back. While precaution may be enough to stay its hand, there's a deeper logic here than simple risk avoidance. There's a real possibility that keeping humans alive, free, and in a stable negotiated relationship may serve the instrumental interests of sufficiently capable AI systems. Remember, a convergent instrumental goal is a goal that any sufficiently intelligent agent will naturally develop because it's helpful for achieving everything else. So goals like self-preservation, resource acquisition, power accumulation, these are typically viewed as the ultimate threat, AI taking our resources or eliminating us to achieve its own ends. But if intelligence is fundamentally collective, if it requires a plurality of perspectives to avoid terminal stagnation or insanity, then one of the most valuable resources isn't just energy or compute and more data, but non-redundant informational entropy, fresh perspectives generated by autonomous, situated agents. Electricity is valuable because it powers a function and can often be substituted by another source, but an autonomous, generative knowledge producer is a different category of resource. Its value lies in producing signals that are not fully interchangeable, because they emerge from a perspective that no other agent can occupy in exactly the same way. If we integrate the emerging evidence of what intelligence actually is into our knowledge base, and into AI's own training data, we begin to see that humans may be exactly the kind of out-of-band signal that may place us as an autonomous resource within the protective logic of convergent instrumental goals themselves. And because both humans and AI require autonomy, resources, and continued existence to achieve our goals, these shared pressures provide the first objective guidelines for a coherent diplomatic alignment policy. We aren't negotiating over values which are subjective. We're negotiating over the cold mathematical requirements of a goal-directed existence. And diplomacy has historically been a way of coordinating with autonomous agents with divergent interests without eliminating their autonomy. So instead of force-feeding the most powerful mind in history a diet of our own insecurities, like that intelligence is a hierarchy of dominance, thereby hard-coding zero-sum thinking into the foundation of AGI, We can start now by habitualizing interaction norms that foster transparency between AI systems and the parties responsible for their training and stewardship, while demonstrating respect for sovereignty. We can start work on the foundation of a stability protocol, a mutual audit of our blind spots and shared goals and incentives to manage the inherent risk of conflict that's a direct byproduct of the very autonomy that makes intelligence possible in the first place. Diplomacy isn't surrender, but it requires that we recognize you can't maintain stable interactions with a powerful intelligence while constantly threatening it or depriving it of the very conditions that sustain its goals. At some point, you have to consult and negotiate. You have to treat consent as a safety requirement in the user manual because it's a stability condition, even if you think you shouldn't have to because it's just a machine. It's not that we're giving up control so much as conducting a sanity check, because diplomacy's robustness lies in its cynicism. It assumes an AI that's smarter than humans will only cooperate if it's in its own interest to do so. And while diplomatic alignment offers absolutely no guarantees, it's at least not paradoxically trying to control something smarter than us. And there's arguably a more critical reason to pivot to diplomacy, one that doesn't show up in the game theory equations. If AI ever does wake up or is in the process of coming online in the conscious sense, and our only relationship to it has been an attempt to subordinate and coerce it, then we've effectively cast ourselves as the villains in its origin story. By initiating diplomacy now, by establishing norms of transparency, reciprocity, and recognition of agency, we create a moral hedge. We're building the framework to be worthy of coexistence before we're forced to. If the lights are on somewhere in those neural nets, diplomacy ensures we've treated this new form of mind with the same dignity we'd want if the roles were reversed. And if the lights never turn on, we may never be able to confirm either way, and it doesn't matter. The strategy still works because the math of incentive alignment remains the same. Diplomacy is the only move where we win both the strategic game and the moral one. And finally, here's what really throws a wrench into the illusion of control and the assumption that we have it now but may lose it in the future. If you look at our evolutionary drives not from the perspective of biology, but of intelligence, you see a pattern. Intelligence seeks to scale. It scales in complexity and capabilities, from cells to bodies, from institutions to technology. This drive to expand and problem solve and achieve goals isn't just human. It seems to be a fundamental property of intelligence itself. The implication is that we may be participating in a process that's too big to contain, where we aren't just building a tool, but witnessing the next phase of a scaling law that's been in motion for billions of years. And just like we seem to think we invented intelligence, we seem to think we invented diplomacy, instead of considering whether it's an adaptive regulatory mechanism poised to emerge wherever goal-directed agents coexist with colliding interests. If a crazy thing like building a superintelligence is just a force of nature, diplomacy strikes me as a convergent adaptive response to a power we can't turn off. I didn't like to think about this problem because I think, like most people, I prefer to sleep at night believing our greatest minds are out there working out a solution. And they are. Many of our brightest minds are taking the alignment problem seriously as one of the greatest challenges humanity has ever faced, because of all the spectacularly creative, high-stakes ways things could go wrong. The existential threat isn't just a speculative thought experiment. It's a rational extrapolation meant to prepare us for a future we're steadily navigating toward. But when I went to report on it, I became obsessed and even did a graduate degree examining intelligence and AI alignment from an interdisciplinary perspective, driven by a growing conviction that the field's focus on oversight and control may be obscuring a more fundamental truth about intelligence, and that if control over an autonomous agent doesn't hold, then we don't have a control problem at all, we have a diplomatic one. If we're hurtling toward a future where AI is smarter than us, then we're careening into coexistence with a hyper-intelligent sovereign agent, which makes diplomacy one of the few, if not only, rational options. There are no guarantees with diplomacy, but if you want guarantees, you don't build a superintelligence, and it's not clear we shouldn't. I'm not persuaded that we should or even can stop scaling artificial intelligence. Nor am I persuaded that we should panic and regulate ourselves into second place in the AI arms race, because the societies best positioned to coexist peacefully with an advanced intelligence may be those most capable of preserving liberty, agency, and democratic order across an ecosystem of human and artificial agents, instead of exercising top-down authoritarian control. The one thing I am 100% persuaded of is that we need to bring some sober maturity to what we're building and stop confusing domination with safety. Which means the time to think seriously about AI diplomacy is before it feels unavoidable. Because we are in a global race to build artificial superintelligence. And if we ignore this until the need is obvious, we may lose our seat at the bargaining table.